Hello friends, good morning. In my previous video lecture, I had started with the last unit of switchgear and protection subject, that is circuit breaker, that is switchgear. In that I had explained what is circuit breaker, what is arc interruption theories, and I had explained about the arcing phenomena and arc voltage. Today I will explain the important terms associated with the circuit breaker. So for this I will recall or I will again go to the circuit breaker operating mechanism. Now as per definition, circuit breakers are nothing but two current carrying electrodes which are normally engaged but separate when their trip coil is energized, and trip coil is energized when relay operates. So sequence is like this: fault occurs, relay detects the fault, it closes its contact. It closes its contact means trip coil of the circuit breaker is energized. So as soon as trip coil is energized, circuit breaker starts operating. Now circuit breaker consists of two poles or two electrodes. They are engaged like this. So when these contacts are intact, in normal condition, load current is flowing through these contacts, and when it is short circuit, fault current is flowing through this. When trip coil of the circuit breaker is energized, they start separating. One contact is fixed, another is moving. So there is transition from current carrying to voltage with a standing state. So due to this, arc is developed between the electrodes. So as long as this arc is there, current continues to flow, and we cannot say that fault is isolated. So when this arc is interrupted, at that time these two contacts are fully separate and fault is removed from the system. So here with this diagram I will try to explain the different terms associated with the circuit breaker. So in this dotted line, I have shown that it is actually system voltage, but I have shown this dotted line means fault is there, therefore system voltage has collapsed. This is the current flowing through the contacts, that is arc current. So as long as this current is there, voltage will not appear and voltage will remain zero, that is system voltage across the breaker. Now this is the instant of final arc interruption. That is at the natural current zero, I have shown that arc is interrupted. So when arc is interrupted, these two contacts are fully separate, arc is not there, one contact will remain connected to the generator, that is at high voltage, another contact will be at the ground potential. So at this instant, we define three terms. First is recovery voltage, that we denote by V suffix RC, recovery voltage. Definition is, it is the normal frequency, it is power frequency voltage that appears across the circuit breaker at the instant of final arc interruption. I will repeat, it is the power frequency voltage which appears across the circuit breaker poles at the instant of final arc interruption. So whatever system voltage is there, that will become the active recovery voltage. Whatever system voltage is there, that will become active, that will become recovery voltage. So simple definition. Next is active recovery voltage. Instantaneous value of recovery voltage at the instant of final arc interruption is called as active recovery voltage. So it is instantaneous value, and where it appears? When it appears at the instant of final arc interruption. So this is the instant of final arc interruption. So whatever power frequency voltage instantaneous value is there, that is the active recovery voltage. And third is restriking voltage. Definition is the transient voltage which appears across the breaker poles at the instant of arc interruption or after the final arc interruption is called as restriking voltage. It is the voltage which appears across the breaker poles at the instant of arc interruption. So it is transient voltage. It is also called as transient recovery voltage. Now we shall derive the expressions for these two terms. This is simple, it is system voltage. Now we derive the expression for active recovery voltage, or alternatively we call this as factors affecting the active recovery voltage magnitude. Then we derive the expression for restriking voltage. So in this video lecture, I will derive the expression for active recovery voltage, or alternatively we call this as the factors affecting the active recovery voltage. factors affecting active recovery voltage, or alternatively the equation for active recovery voltage. This is the diagram. First factor is system power factor angle, that is phi. Now we have expression Vt, that is voltage, is equal to Vm sin omega t, and current is Im sin omega t minus phi. Phi is the angle by which current is lagging the voltage. Now at the instant of arc interruption, final arc interruption, that is current 0 instant. So It is 0. So in this expression Im cannot be 0. So this sin omega t minus phi will be 0. It means omega t will be equal to phi. Now substitute this value of omega t in this expression for the voltage. So we get Vt is equal to Vm sin of phi. Let us say this is first point or first factor. So we can say that active recovery voltage depends on sin of power factor angle, sin of phi. Second factor is armature reaction. Now current, that is short circuit current or fault current, is lagging in nature, that is inductive in nature. Now when current is inductive in nature, it generates demagnetizing effect on the armature reaction. So armature voltage slightly drops. So generator terminal voltage due to demagnetizing effect drops. Therefore the system voltage reduces. So to introduce the effect of demagnetizing armature reaction, we consider factor kdm. So we write Vt is equal to kdm Vm sin phi, where kdm is less than or equal to 1. Actually it is less than 1, but if it is not mentioned, we assume that it is equal to 1. Now I will discuss the third factor, that is circuit condition. Third factor is circuit condition. So here to explain this circuit condition, I have shown three-phase system: generator, A phase, B phase, C phase. This is three-phase circuit breaker. One denotes contact connected to generator, two denotes contact connected to the line. Now from previous discussion, it is obvious that during fault condition, the power factor of this power factor angle phi is 90 degree. So let us assume that kdm is unity, power factor angle is 90 degree. So sin of phi is 90 degree, that is it is 1. So active recovery voltage is Vm. Now let us start with phase A. Now this is three-phase circuit breaker. Short circuit has taken place, relay have operated, so these contacts are start separating. Now let us assume that the arc interruption first takes place in phase A circuit breaker contacts. At that time, phase B contacts and phase C contacts, they are still arcing. So first case I am considering is system is grounded. This system neutral is grounded. I have shown here the grounded fault. Now pole 1 of phase A, let us say potential is V1. So that will be equal to VA, that is A phase voltage. Now VA is sine of VA is VA is Vm sin omega t. Now power factor angle is 90 degree. So at the instant of arc interruption, this omega t is 90 degree. So VA, which is equal to Vm sin omega t, will be equal to Vm. Now this part is grounded. There is a still arcing. These contacts are still arcing, but this contact is at zero potential or potential. So V2 is at zero potential. Therefore, potential difference between 1 and 2, that is between the circuit breaker contacts, is Vm. So this is the case when system neutral is grounded. Now let us consider the second case when system neutral is not grounded. So this part will not be there. This part may be there. Now again consider same condition. Contacts of breaker in phase A, in that arc interruption takes place initially. First arc interruption takes place in phase A. At that time, this contact is arcing. This C phase contacts are also arcing. Now this part is not there because system neutral is not grounded. So one will remain connected to phase A, and as we had assumed omega t is 90 degree, VA is Vm. Now at that time, this contact will go to potential VB or it can go to potential VC. Now VB is Vm sin omega t minus 120. Omega t is 90. So substitute omega t is equal to 90. So we get VB is 0. minus 0.5 Vm. Or it can go to potential VC. So VC is also Vm sin omega t. That is omega t is 90 plus 120. That is also 0.5 Vm. So contact 1 is at potential Vm. Contact 2 is at potential VB or VC and both are equal to 0.5 Vm. So if you find the potential difference between contact 1 and 2 is, it is Vm, that is V1 minus V2. So Vm minus of 0.5 Vm, that is 1.5 Vm. So this factor comes into picture. It means if system neutral is grounded, this factor, K circuit factor, we are denoting this factor by K circuit, it is 1. If system neutral is not grounded, this factor is 1.5. So this is called as circuit factor. Now we'll combine all these three factors. So after combining all these three factors, we get the active recovery voltage equation, K circuit, KTM, Vm sin phi, where K circuit is 1 if system is grounded, if system neutral is grounded, it is 1.5 if system neutral is not grounded. K's, it is circuit factor, it is demagnetizing armature reaction factor KDM, this is less than 1, but if it is not given, we have to assume this 1. So conclusion is, the active recovery voltage depends on three factors. Number 1, power factor of the circuit. Second, demagnetizing effect of demagnetizing armature reaction factor KDM. And third, circuit factor, that is KT. It is 1 for grounded system and it is 1.5 for ungrounded system. So that is all about the active recovery voltage. In my next lecture, I will explain restriking voltage, that is transient recovery voltage. Friends, if you feel this video lecture useful, then please like it, subscribe to my channel, ask your friends, colleagues and juniors to subscribe to my channel for upcoming video lectures on power system protection and high voltage engineering. If you want to make effective and efficient use of time, then read my book on time management. Link for the book is given in the description box. I have launched a useful course for students on UDEMY. This course is specifically useful for the students who are preparing for entrance and competitive exams. The link for the book is also given in the description box. Thank you.